Hello, Ali.
Hello, Caio. Hello, Mike.
Hi, Ali.
Thank you for joining us.
Thank you for inviting.
Yeah.
Are you an iOS developer?
Yes.
For how long?
For about 6.5 years.
Okay.
Awesome. Senior developer.
Senior developer, yes.
Awesome. How can we help you?
You can say so.
How can we help you?
Okay, so recently I wrote a feature in which I have to implement messaging, sending message and sending files to your friend. So we thought that we implement XMPP protocol for that, right? So I found that there are some different protocols we can implement too, but currently we implement XMPP. But in case I want to implement another protocol with the same modular framework, like XMPP, I wrote a framework which helps me to connect with the XMPP server, and I can get all the features of the XMPP protocol, right? So in case tomorrow or in future, I want to implement Socket.io for the Socket.io protocol. So how can I write that code in a way that both of them are adjust in the same framework, and it doesn't hurt my core application?
Okay.
So how to decouple your application from a specific protocol like XMPP. So if you want to change this protocol, you can do it, correct?
Correct.
Right. So there are two key principles, that allows extensibility of the system and replaceability as well. And the principles are the open-closed principle and the dependency inversion principles. They are the main ones related to this topic, right?
Okay.
For example, the open-closed principle states that a component should be open for extension, but closed for modification. Meaning that when you follow this principle here, the open-close principle, you should be able to extend the behavior of a class, a component, a module, without making changes to it, right? And there are multiple ways to achieve it. You have polymorphism, you have composition as well, And the idea is, if new requirements come in, ideally, the new requirement should be added to the code base without changing existing code, right? For example, you mentioned that you can send messages to this protocol, and maybe tomorrow you also need to send audio or video or a sticker, You should be able to add these new features without changing existing code. That's what this principle gives you. If that's what a trait you want in your code base, you can follow the open-close principle because it dictates that you should be able to add new features without changing existing code, right? And the other principle that supports the extensibility, the open-close principle, is the dependency inversion principle. For example, I have a diagram here, right? We showed this diagram the other day here as well in the mentoring session. Let's say you have the infrastructure here using XMPP, right? You have your application. Instead of your application talking directly with XMPP, with the framework you created, if you do this, you're coupling the app with XMPP, which also is going to couple it with XMPP details, the way the communication needs to be established, the way the communication is, they change, they exchange messaging and so on. Well, what do you do rather? You put a boundary here, which can be like any kind of abstract interface, can be a protocol, a closure, whatever makes sense to the use case, to invert the dependency. Now look how the app doesn't depend on the XMPP anymore, but your XMPP component depends on the app. So you're inverting the dependency. instead of depending directly on the infrastructure, you make the infrastructure depend on your application. Thus, if you want to change here to socket IO, you just have to do it here. Well, socket.io. You do it. You just replace this component. Your application is unchanged. Right? That's the dependency inversion principle that will support this use case that you want, right? If you want to be able to replace a specific protocol, a specific framework, a specific component, you invert the dependency. This is one way of doing it. And then in your application here, you define the use cases you need. You define the modules you need. Like you may have here a text message, for example, and then tomorrow your boss comes to you and say, hey, we also need to upload audio messages. And then you have an audio message model as well. And you define here exactly what your app needs without leaking details about which protocol I'm using behind the scenes. You know, so here text message probably would have what a text string, right? An audio message could have here the audio data, right? Then you can have maybe a video here. Also, I don't know, a video message with data as well. And you add this new functionality to your application, you know, without changing the text message or without changing the audio message, you can add the video message, for example. And it's up to the implementation here to be able to handle an audio, a message, you know, because each protocol will have a different way of uploading different kinds of media, right? And then it's up to the frameworks to fulfill the app needs. So you define the needs your application needs, you know, in its own module here, decoupled from how it's going to be done. You set some boundaries here. You set your models here, decoupled from the framework. Then you create your framework component implementing the use cases that the specific application needs. And then you are free to replace sockets.io, XMPP, whatever you're using, Firebase, you know.
Yeah. And you can see how these entities there, these models, they don't have any orange, you know, any infrastructure details in them, right? That means that allows your system there to be open closed in a sense, right? Because the use cases, the entities, these models, they will not know, you know, the infrastructure side if you're using sockets.io or if you're using XMPP or whatever, right? Now, the moment this doesn't happen and you start leaking even the slightest implementation detail in your model, it's done, you know, like you lose this open closed trait for your system. That's why it's so important to follow this dependency inversion principle and understand why you need this boundary in between your domain logic and the infrastructure of your system. So,
okay, so like it's in the orange box, right? Mm-hmm. So for suppose if socket have a room implementation, should I write in the purple box or should I write in the orange box?
So if the concept of having rooms is decoupled from, so it's saying like a chat room, right?
Right.
Yeah, so if your boss comes to you and say, okay, you can send a message to one person, now we want groups as well. This is something your application needs, right? It's part of the application you're building. So you're going to define what your application needs here in this box. You're going to talk about rooms, you know, you're going to say, okay, now we're going to have the concept of a room, for example. Right? And maybe a room has like users, right? Like an array of users, something like this. You define here whatever your application needs. You know, you're going to define the models here. You're going to define the features it needs here like a user, for example, that is going to have, I don't know, a nickname. And you see, like a nickname, like a string, is not specific to sockets.io, right? It's not specific to that. So a room is not specific to sockets.io. It's just a concept of having a room with a lot of people, right? And it can be also decoupled. And then let's say the app needs a use case to create room, right? Then you can have here like a create room feature or use case. And at some point, it needs to ask the infrastructure to actually do it, right? And then you're going to have an interface here like, I don't know, room service, like this. Don't get too attached to the names here. They're just examples. Yep. You're going to name it depending on what your application needs, okay?
Right.
And then the sockets.io, let's say you have a module using sockets.io. You want it to create rooms for you, right? The application at some point is going to say, hey, room service, create a room for me. And here are the settings. I want to create a room with these 3 users here. Now it's up to the sockets.io implementation to know how to do it, but your application doesn't know how it does it. The application just defines the features it needs, and the boundaries, interfaces. And it's up to the frameworks to implement it.
Okay.
And here is like an adapter, right? This is like a socket.io adapter. Right. Because if you're using a library, for example, sockets.io library, not make a library depend on your code, right? A library doesn't depend on your code. A library is generic. So you're going to have something like this. You're going to have here like an adapter layer, pretty much. That will
sort of controller
this communication between them,
Yeah.
And here, maybe if you use the sockets.io Swift library, right, that they provide, they have a function there, create room, right? They have a way of creating a room. And this adapter here will receive a request from your application. Your application say, hey, I need you to create a room with these users, with these details. Now this adapter will unpack that request and say, okay, this is what the application wants. Now I'm going to tell socket.io to do it in the way the socket.io does it. Right? So if one day you want to replace this with whatever other service here, you just have to re-implement the adapter, Whoops, adapter. Just re-implement the adapter. The application doesn't change because you're decoupling the application from specific framework details, which means here you shouldn't leak any detail about XMPP. Even if it's convenient to add something here that's specific to that protocol, I recommend you don't do it. Do it in the adapter layer, the transition from your application needs to the framework needs.
An easy way to know if you're doing it at the time is like check if in the app or like the domain part of your app you type import, and the name of the library. If you say import sockets.io, done. You're doing it. Doesn't matter exactly if it's like the slightest convenience. It violates the open close principle right there.
Okay.
Absolutely. Yeah, but you do this when you want to actually decouple from the protocol, right? From a framework. For example, if you want to decouple your application from core data as well, as we show in the course, it's a choice, You don't have to. It's a choice you're going to have to make with your team if it makes sense to your project to decouple it from the protocol, because we're not too attached to the protocol, Our application is about sending messages and we don't want to be too attached with the protocol. Maybe you're going to use the Signal protocol at some point. We want to encrypt everything, do like end-to-end encryption. There's many things you can do here. And if you want to decouple your application from those details, you can. You can follow the dependency inversion principle and the open-close principle. So you can add features without breaking code all the time. And you can also decouple from specific frameworks so they are replaceable if needed.
Right. So what if I want to use both in the same framework? Is it the right way to do that, or it should have a separate framework?
You mean,
You want to
when you
use
say both, you mean XMPP and Sockets.io?
Yeah, yeah, right.
Yeah.
I mean, you can have two frameworks, right? For example, that implement the same protocols. Let's say if you deploy these chat applications to multiple clients, and some clients want to use XMPP, some clients want to use Sockets.io, some clients want to use Signal. I recommend that you separate them, because if a client wants XMPP, he probably doesn't want Sockets.io. You never use them at the same time. So you can create separate modules, right? Let's call it green. I like to use colors too. To show, yeah, something like this, right? Then you have this green one here that also implements the protocols, and then it's up to the client to decide which one they're going to use. So here is Sockets.io, for example. Make sense?
Makes sense.
So they can be in separate modules, and then you can deploy them independently to your clients. If a client wants just Sockets.io, there's no need for them to bring these huge libraries along with it, and vice versa.
And again, the app doesn't know which library is being used, right? This is a composition detail. You're gonna have to decide that in the composition root of your application. Again, no arrow points from the purple to the green or the orange boxes.
Perfect. Perfect. So as you said, Mike, if I import something in the application, like if we have a XMPP room, I have a class which name XMPP room, right? And I
Yes.
import in the application. That's break the open close principle, right?
It depends what you mean by application, right?
My main application.
Do you mean like, if you want to decouple, when I say here app, I'm talking about more in general terms, but if you're saying like, oh, in the app delegate, in the composition root, for example, if you are in the application module where you do the composition, that's okay to import XMPP, because you need to do it to compose everything together, right? But if this whole logic here is in an independent module with no application, for example, it shouldn't import XMPP or Sockets.io, right? Let's say this is the chat module, and then you have many applications, right? You can have application for client A that composes with XMPP. In the application module, which is the main module where you do all the composition and boot your application, the main function that starts the application, there it's fine to import XMPP. But then you have another client. You have another client, they want Sockets.io. You're going to create a new application, right? A new application target for that specific client with all the settings they want, and you will compose with Sockets.io in that main application module in the composition root. But the modules you want it to be decoupled from specific frameworks, from specific protocols, they should not import specific frameworks and protocols.
Yeah.
Perfect.
Yeah. So you should have your own models there, right? I don't know if you're about to say that I have a class called XMPP room, and this can represent this room entity, and maybe you want to use it now in another service, and this other service has to import the XMPP because of this class. No, yeah, should have your own entities representing the concepts that make sense for your domain, for the business, for the app.
Yeah. Again, if you want to decouple from the framework, if you're happy to couple with Sockets.io or XMPP, that's fine. But just know that in the future, if you couple it, it's going to be much harder to to replace it with something else.
Exactly.
It's a choice. But this is one way you can do it. And you compose with the framework in the composition root, in the application main target. right? Because this could be an independent module. It doesn't even need to be an application, right? It could be a framework. This could be a framework. This can be a framework. This can be a framework. And then you have an application target that composes all the modules the way they want it to be composed, like Lego blocks, plug and play.
Right.
Any other question?
Okay, so my other question is related to the unit testing. So for suppose I have a controller, spaghetti controller, having thousands of lines, and I want to test that controller, right? And it having a dependency, but it's using concrete types. No mock, in sense that you cannot mock any other abstraction in the controller, right? So how can you test that?
Well, if you're testing, let's say, and there is like a network, there's a network request inside this view controller, and you can mock it, right? You can test it making the network request. It's just going to take a long time to run, and also will probably be flaky, because if the internet connection is dodgy or you don't have an internet connection, it's going to fail, right? So this is one way. You can just test it through the UI. Your UI test is going to take forever to run, but this is one way of testing it. Now, if you want to make it more reliable, if you want to make it faster, you need to then start decoupling your application from these specific components. You can start using dependency injection as well to inject the mocked or the test doubles instead of the real dependencies, right? As we show in the course. And there are many ways you can use dependency injection. Like in legacy code bases, it might be advised to start with a ambient context, which is an ant pattern, but it's one step closer to solving your problem. For example, let's say the view controller is accessing a network component singleton directly, right? So it's hard to replace it because it's not injected. It's accessing the singleton directly. What do? You can make instead of a singleton, you don't make it a singleton anymore. You make the shared instance be mutable. So when you're testing, you can replace that shared instance with a test double, like a mock or a fake or a stub or a spy. But that's not ideal. But if that's the easiest thing you can do just to get testing in place, fast and reliable tests, that's the first step. And then with time, you start cleaning up the code little by little. Don't make like big changes. Don't ask your boss for a month to refactor, because they're not going to give you the time. But little by little, you start cleaning up, injecting the dependencies when you need to, separating dependencies, not even injecting, sometimes even completely removing dependencies from the view controller. So the controller doesn't even need to make all those decisions, and everything starts getting easier and easier to manage. Follow what we did there in the course, go through the challenges, and you'll see how you're going to structure your application that the UI doesn't even know that there is network connections. It doesn't even know that there is databases or things like that. So when you eliminate dependencies, things get much easier to test. And then you compose them in the composition route, as we discussed here. And everything is much easier to test because you eliminated the dependencies.
Yeah. And you can also see in the course the progression from ambient context to better ways of dependency injection, like initializer injection, like step by step, how you can start removing implicit dependencies like singletons from your components.
Yeah, we showed in the first lecture. If you watch it again, pay attention that we show like different ways you can start testing, because we want you to have options, because depending on the code you're dealing with, you're going to use different strategies.
Yes.
Yeah, right.
But dealing with singletons, there is specific strategies you follow to refactor the code until you have a way of injecting the dependency or eliminating the dependency.
Yeah.
Okay, so what I experienced that that controller having sort of 4,000 lines of code, and there was a dependency of analytics, crashlytics, and API requests, and much more related to the feature like search, filters. That's all written in the same controller, right? So how can I mock that at the same time? Because when I initialize that controller, it's doesn't respond because it shows error to me. Like, for suppose there is a third-party analytics tool. So when I write the test and initialize the controller, it asks me to initiate my analytics third-party dependency first.
Eliminate the
So-
dependency. You can use, for example, a delegate.
Yeah.
Instead of calling the analytics framework directly, you can set a delegate. Again, instead of making your, let's use dependency inversion here. Imagine you have a view controller and you have like a analytics library, right? Instead of making the view controller talk directly with the library, you can introduce, for example, a delegate here. So every time the view controller receives an event or need to, deal with this event, pass this event forward, like a user tapped a button, or a user selected an action, or a user filtered the feed, and you want to, track those events, simply the view controller would just send a message to the delegate, hey, this happened, send events. You design your application, your view controllers to send events and not make decisions what to do when those events occur. Because then you can test all of this without the analytics library, for example. We have a series here on YouTube. Search for it. Clean iOS Architecture Analytics. And we show ways you can do it using composition, using a bunch of strategies. There are many ways we show there to do specifically with analytics, And then you decouple your view controller from specific framework, because otherwise you need to start the framework and you need to set configurations, and maybe it's going to make an internet, it's going to make an internet request, a network request, and it's going to take forever, and maybe it's going to crash. Yeah. You don't want that in your tests, You want your test to be isolated and run on its own without many dependencies. So check Clean iOS Architecture Analytics on YouTube. That's one. Go back to the first lectures where we show like how to deal with like singletons and these ambient context anti-patterns. What else? Big view controllers. If you have 4,000 lines of view controller, because there are actually a lot of features in the view controller, like filters, like search and other things. I recommend that you break down in many view controllers as well, right? Instead of having a view that is like one view controller that does everything, one screen in your app doesn't need to be one view controller. It can be many view controllers communicating with each other, like tiny MVCs. It's in the course as well. In the UI module, we show how to create tiny MVCs. They interact with each other. So watch there in the UI module as well, how to get a massive view controller and break it down into tiny independent MVCs and making them communicate. And then you can test one at a time. You can test the search in isolation. You can test the list in isolation. You can test like navigation in isolation and so on. Any other questions?
Not now.
Awesome. Thank you for joining us.
Thank you.
Great questions.
Yeah,
Thank
absolutely.
you.
Awesome.
Thank you, Caio. Thank you, Mike.
Thank
Bye.
you. Bye-bye.
Take care.